Okay, we're in section 19, which is the rational exponents. So in the past, we basically did exponents that were just integer, all right, like 0, 1, 2, 3, and they're negatives, -1, -2, -3, so forth and so on. The rules that you've developed in the past still apply, all right? So, certainly we'll go to the whiteboard and we'll talk about those rules over there. And someone says there's way too many rules for me to understand. If you remember in the past, we just concentrated on 3 rules, 7, 8, and 9. And we concentrated on the meaning of an integer exponent. All right. Now, once you understand the meaning of an integer exponent, my claim over here is that it's fairly simple to comprehend the meanings of these things over here. Not to memorize, but to comprehend that. Negative powers, they can be a little difficult, but for the most part, we try to resolve that by writing them as positive powers. All right. Now, again, the whole concept of developing this rule set is understand the meaning. So we also want to understand the meaning of what it means to be a fractional exponent. But if you don't understand the meaning of a whole number or integer exponent, you're going to have a real tough time understanding this fractional exponent business. But we'll go through that. I'll go out the whiteboard. Here's the problem though. A lot of times what happens to students is they see this lecture and there's no comprehension of what's being presented to them. That's going to happen to you, not just here, but in other schools as well. You're going to hear things and not really know how it applies to what they expect you to be able to do. So we will get to examples, but before we do that, there will be a short lecture. Then we'll go to examples to try to make more clear what we're presenting in the lecture portion. So let me go over to the whiteboard now. Just give me a second. And I got to do something here. Okay, we're doing rational exponents. Before we do that, though, my claim over here is that we have a past, and the past is in the integer exponents. And so, for example, that common past we have, I'm hoping you realize we said certain things. And the things that we said initially were, you should understand the meaning of an integer exponent. You may have to go back and review that though, right? It's possible. For example, in the past, when I first started this thing, I'd say x to the 1. What does it mean? 1 factor of x. X to the 2. I meant that's 2 factors of x. X3, that's 3 factors of x, so forth and so on. Then if we went to x0, what does it say? Well, we have no factors of x. So then I start to realize we have coefficients here. 1, 1, 1, and that would be a 1. And then we did negative exponents. We did something like this. I still said it's coefficient of 1, but now there's 1 factor of x in the bottom. Now, granted, if you don't recall that, you got to go back a really long way to the beginning of the course where we covered all that material and repractice those examples. My claim is this, though. Once you do that and you understand the integer exponents, it's not going to be a big jump to these fractional exponents. But I want to point out a couple of rules over here that I want you to really focus in on. Number 7, we talked about that in the past. This is our past. Number 8, we talked about this in our past. And number 9, we talked about this in our past. The intent of these things, though, is to rewrite negative exponents as positives. All right. Now, my other claim about these problems over here is that I'm going to claim that some rules should be really simple, that you develop these over time, but they should be really simple rules. We want to continue with those simple things. All right. And this one over here. Now, someone says, well, there's other ones over there. You're right about that. For the most part, check this thing off. I'm going to say it's nice to know this, nice to know this, nice to know this, nice to know this, and this. All right. And someone says, there's other ones there. Can I know those too? Yeah, over time, everything should become more obvious to you over time. It should. But again, meaning of an integer exponent needs to be well understood before you can move forward. All right. Let's go to the next page. And we'll talk about meaning now. All right. One step at a time. So if you remember the past, if I brought down 4 to the second power, its meaning was they wanted 2 factors of 4. What does that mean? 16. But now when they put down 4 to the 1/2 power, what they're asking for, they're asking for one of the two equal factors of 4. Let's write this down. They want one of the two equal factors. Well, someone's gonna say, what are the equal factors of 4? It's 2, because 2 times 2, they're both equal, and 2 times 2 is 4. And what would that give you? Just 2. All right, that one's done. Let's do 9 to the 1/2. I'll write this over here. What's the meaning over there? They want one of the two equal factors of 9. Well, what are the equal factors of 9? 3 times 3. Why is that? 3 times 3 is 9. What's one of those two equal factors? The number 3. Let's do 8 to the 1/3 now. What do they want over there? One of the three equal factors of 8. Well, the three equal factors of 8 are 2. 2 times 2 times 2 is 8. And one of those things is just 2. All right, let's do this one over here. 64 to the 1/3. And I'm sorry, I put down 1/4. I meant 1/3. What are the equal factors? Well, if I can't get them, I can't get them, but I think I can. 4 times 4 is 16, times 4 is 64. Well, what's one of those? It's just 4. All right, let's keep moving on. And again, meaning is everything. Do you understand the meaning of this? Let's write this one down. This is 8 to the 2/3. These are fractional powers. What do they want? They want 2 of the three equal factors of 8. Well, the three equal factors are 2 times 2 times 2. Well, 2 times 2 times 2 is 8. But what do they want? They want 2 of those factors. So what's it going to be? 2 times 2. What's 2 times 2? 4. All right, let's put this one down. 64 to the 2/3. And again, we're just going across meaning now. What do they want? 2 of the three equal factors of 64. Well, the three equal factors would be 4 times 4 times 4. Again, 4 times 4 is 16. 4 times 4, I'm sorry, 16 times 4 is 64. They want 2 of those things. And what would you get? Well, 4 times 4. What's 4 times 4? 16. All right, let's do this one, 32. And by the way, they're going to give you problems you can do. This would be awful to give you things you can't do. They want 3 of the 5 equal factors of 32. Well, it looks pretty simple. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Let me make sure I understand what this means. 2 times 2 is 4, 8, 16, 32. 1, 2, 3, 4, 5. They want 3 of those factors. Right? They want 3 of them. 2 times 2 times 2, which is 8. All right, 81 to the 3/4. What do they want? 3 of the 4 equal factors. 3, 3, 3, 3. They want 3 of the 4 equal factors. That would be 27. All right. Now, granted, I want to just talk about other thing with these is there's going to be notation for the fractional powers. All right, notation. All right. What's problem with notation? It gets in the way of understanding sometimes. I do like the concept of a rational exponent where they explicitly state what the rational number is. A rational number is a ratio of integers. But now they're going to use a different notation. Don't be intimidated by this. It's just a different notation. And by different notation, what I'm talking about is you're going to see the rational power. And write down what I mean by this. You're going to see x raised to some rational power. They have another way of writing it down, and they use what's known as radical notation to do it. And they're saying it's a root now, and this is the root notation. It's the root of x. Which one is it? It's the nth root. All right. I'm going to point out things to you. This thing over here, that symbol there is a radical, or it's radical notation, it's a root. This n over here is called the index. What's the index over here? It's going to be some whole number. And what's x? X is the radicand. We'll talk about another one. We'll talk about this guy over here. A little more complicated. I want to point out, if I see this one over here, I'll write this down for you. X, whoops, let's go back to black ink here. With the understanding that m and n are integers. All right. I'm going to say the same thing as x to the 1 over n raised to the nth power. And what does that mean? It means the nth root of x raised to the nth power. That's fine to put that down, by the way. Again, we could also write this differently. I'll write it over here for you. This could be written as x to the m to the 1 over nth power. What does this look like? Well, it looks like the nth root of x to the m. All right, let me put out what this written for you over here. Now, granted, I realize a lot's been said. All right, one is rules from the past. You're going to need to use those rules. What else did we just talk about? The meaning of a rational exponent. What else did we talk about? Radical notation. As time goes on, this will grow. But right now, we need to get to examples. As we do the examples, we hope the concepts that we discuss become much easier for you to deal with. Thank you.